5. Alright, so how do you find the inverse of y equals ln x? So let me talk about inverse functions for a second, okay? So we know that our function, let's say f of x. So function f of x, basically what that does is, okay, so we'll have a pool of x values, okay? So these are our x values, okay? So it takes one of our x values, and then we punch it through f of x to get a bunch of f of x values, okay? So let's say f of x equals y, which equals something else, okay? So we'll make it distinct here. So we have a bunch of y values, okay? So what the inverse function does is that it reverses what the f of x function does. It takes values of y and brings it back and maps it back to a value of x. Okay, so the convention is to write an inverse after the f like this. So inverse of f of x will take a value of y and map it back to a value of x. Okay, so when they're asking us to find the inverse of y equal ln x, there's a technique that we can use. Okay. So the technique is that we want to swap x and y, the places of x and y. So if our original function was y ln of x, to solve for the inverse, we're going to first of all swap x and y. So now we have x equals ln y, and now we're going to solve for y. So let's apply the natural Euler's number to both sides, or Euler's number, I guess. So e to the x equals e ln y, and we know because of our property of ln that this equals 1. So now all we're given is y equals ex, and we're going to write it in its convention, f of inverse x equals e of x. So now we have found the inverse function of our original function, which is e to the x. So this is what the junior tutor did. And this is the correct solution. So they swapped places with x and y. They applied Euler's number to both sides. They used the property of Euler's number and ln to simplify the right side. And all they're left with is y equals ex. And then they found their inverse function. So this is the correct solution. Good work. Cool. All right.